Today's notes are on applications of determinants. The previous notes were on how to find determinants, so we should be okay with that. We should have practiced that a little bit. Today's notes are on what they're good for, what we can use them for. So we're going to go through two different applications. Okay, first application, first example here, we want to solve this system of equations. Now let's think about all the ways we know that we could solve this system of equations. We could graph these two lines and see where they intersect. We could combine these equations, get x or y to be eliminated, and solve by adding these together. We could use substitution, solve one of these equations for x or y, plug it into the other equation. We could plug these into a matrix and use reduced row echelon form. We could use inverse matrices. Well, today we're going to talk about another method, and that's using something called Cramer's rule. Here's how Cramer's rule works. Let's say we want to solve for x. To solve for x, I'm going to make a big fraction here. We're going to get some quantity on top over some quantity on bottom. The quantity on bottom is going to be the determinant of these coefficients. 4, -2, 3, and -5. The top of the fraction is going to be another determinant. But instead of these coefficients, it's going to take these two solutions and put them in place of the x coefficients. And the reason it's in place of these two is because we're solving for x. So I'm going to put 10 and 11 in these first two spots and keep the other coefficients as they are. Okay, so let's find the determinant of each of these. On top we have -50 minus -22. Okay, I'll write that out. -50 minus -22, which is equal to, let's see here, -50 plus 22, which is -28. On bottom we have -20 minus -6. And again, if we figure that out, it's -14. So x is equal to -28 over -14, so x equals 2. Now we can find y the same way. So I'm going to say y equals, put a big fraction here. The bottom is going to be this determinant formed by the coefficients, which if you think about it, I don't even need to write this out really because I know that value is going to be the same thing we got when we found x, so it's going to be something over -14. On top, it's going to be a determinant. However, we're going to put the solutions in place of the y coefficients because we're solving for y. So 10 and 11 are going to go in this spot, 4 and 3 in this first spot. So this determinant will be 44 minus 30. And we find that y equals -1. So our solution is the point 2, -1. So we have yet another method we can use to solve a system of equations. This will work no matter how complex the system. It's called Cramer's rule. Okay, that's one application of determinants. Here's a second. Let's say we're given 3 points and we want to find the area of the triangle determined by those 3 points. Now if you think about this, this can be a very complex problem. If I give you any random 3 points, well, we could figure out base times height somehow. We could figure out the length of those sides and then use Heron's formula. This formula here is the best way to do this. So here's what this is saying. To find the area of a triangle, we take plus or minus 1/2 times the determinant, that's what these mean, of, now these points here, x1, y1, x2, y2, x3, y3, and then 1's in the right-hand column. We need those 1's there just so we have a square matrix. And the points you can put in any order. The half comes from thinking about the area of a triangle, 1/2 base times height. Now, plus minus. Plus minus does not mean that your answer could be positive or negative. It means whatever you happen to get, make the answer positive. Okay, so keep this in mind. The answer will always be positive because it's the area of a triangle. Now, if your points happen to be on the same line, you think about it, 3 points on the same line, you can't find the area of that triangle. So if you get 0 for this, that tells you that your points are collinear. So really this formula has 2 applications. One application is to find the area of a triangle. One application is to test whether 3 points are collinear or not. Okay, so let's go to an example. I'm giving you 3 vertices, and we want to find the area of the triangle determined by these vertices. We could graph these, we could find these in a number of different ways. Now that we know this formula, here's the easiest way to do it. The answer is going to be 1/2 times this determinant. We'll put the points in here, so I'm going to put 1, 0, 2, 2, and 4, 3 into my determinant. And I have to put a column of 1s in here just because, hey, we can't find the determinant of any matrix besides a square matrix. Okay, now we can find this determinant a few different ways. One method we learned before was let's just copy some of these columns again. So there's the first column copied again. There's the second column copied again. And then let's just multiply along these diagonals. So 1 times 2 times 1 is 2, plus 0 times 1 times 4 is 0, plus 1 times 2 times 3 is 6, minus. Now let's talk about these other diagonals. 4 times 2 times 1 is 8, minus 3 times 1 times 1, which is 3, minus 1 times 2 times 0, which is 0. And if we add all these together, we get, let's see here, 8 minus, we get -3. Now careful, -3 is not your answer. Don't forget the half. That's the biggest mistake people make. So we have to take 1/2 times whatever we find. Now if you do that, you get -1.5, or -3/2, -1.5. But remember, we're talking area here. Remember, there's really a plus minus in front. The plus minus does not mean the answer is positive or negative. It means make your answer positive. So your answer is 1 5/10, or 1.5 square units. Okay, so 2 applications of determinants. There are many more, but these are the 2 we're going to focus on. We can use determinants to solve a system of equations using Cramer's rule, and we can also use determinants to find the area of a triangle given the 3 vertices of that triangle.